Alright friends, let's look at this question. As I keep saying, feel free to pause the video whenever you wish to think ahead of me, because the more thinking you do, the better it is going to be for you, the more you're going to learn, and the more smoothly you will understand these questions. Let's see what's going on here. So the stem of the question, the basic information we're given before we were given like the ABCD, is let f be a function defined by that, and so this is a piecewise function. So they could ask us about continuity, where we have to plug in 3, so we have to look at the limit as x goes to 3 from the left, and the limit as x goes to 3 from the right. And if those are equal, then the function is continuous at 3, and if they are not, then the function is not continuous at 3. They can ask us about differentiability. It's going to be the same idea, except right here it's going to be f prime, and right here it's going to be f prime. So both those pieces they could ask us about. They can ask us to integrate one piece or the other piece or the whole thing. If they ask us for the whole integral 0 to 5 for f of x, we're going to have to do it in two different pieces. We're going to have to go from 0 to 3, and then from 3 to 5. Now the reason we have to do that is because we have two different functions there. So even if they are continuous, I still need to treat it as two different integrals, because like this area is going to be a triangle, and then this one's going to be a curve that looks like this. So we have to find those areas separately. Let's see what we got. Alright, so first question, as I suggested, was going to be, are we continuous? So the limit as x goes to 3 from the left is the square root of 3 plus 1, which is 2. And then the limit, so we dealt with this function because we say less than 3 right there. So if we're less than 3, that's to the left, so hence the negative on the limit. And limit as x goes to 3 from the right, that's going to be 5 minus 3, which is 2. And now you have to explain. So I'll say yes, f is continuous at x equals 3 because limit as x goes to 3 from the left is the same as the limit as x goes to 3 from the right. Ooh, I missed a piece. So this, I just paused because I was processing what I wanted to talk about. I also need to check what f of 3 is. F of 3, since this is the equal to portion, f of 3 is also 2. So I need to put that part. If I don't put, it's okay. If I only put this part, that means the limit exists. That does not mean that the function is continuous. That means the limit exists. In order for the function to be continuous, I need to talk about the function value. So in order for a limit to exist, the limit from the left has to equal the limit from the right. In order for the function to be continuous at a point, the limit from the left has to equal the limit from the right, which means the limit exists, but we also need that to equal the function value. If we don't have that function value part, then we cannot talk about continuity. Find the average value on the closed interval 0 to 5. So that means I need to integrate 0 to 5 f of x dx, and then I need to divide by 5. So let's pause on that. I already talked about this earlier. In order to integrate 0 to 5, I need to go 0 to 3. And instead of writing f of x, I'm going to write the square root of, actually I'm going to write x plus 1 to the 1/2 dx. Now I'm going to find whose derivative that is. So that's going to be to the 3/2, because I'm going to add 1 to the exponent. But don't forget 2/3 in front. I'm going 0 to 3. Now when I plug it, I'll show my work here. When I plug in, I'm going to put the 2/3 out front, 3 to the 3/2, and then I plug in 0 to the 3/2, and that's going to be, keep the 2/3 out there. 3 plus 1 is 4. Now this 3/2 piece, that means take the square root, so the square root of 4 is 2, and then cube it, so that would be 8, because 2 cubed is 8, and then that's going to be 1 to the 3/2, which is going to be 1. So that's 7. and then that's 14 thirds. 14 thirds. Now I also need to do 3 to 5. 5 minus x dx. I'm going to do it analytically, and then I'm going to show you how you could have done it using a picture. 3 to 5. So the derivative, whose derivative is 5? That would be 5x. Whose derivative is x? That would be 1/2 x squared. Let's go ahead and plug in 5. That's 5 times 5 minus 1/2, 5 times 5. Minus 5 times 3 minus 1/2, 3 times 3. And that's going to be, okay, that's 5 times 5 minus 5, half of 5 times 5. So that's half of 25, because that's a whole minus half. And then that's 15 minus half of 9. So minus 15 plus half of 9. So 25 halves and 9 halves makes 34 halves. So that's going to be 34 halves minus 15, which is 30 halves. So that's 4 halves, which is 2. So that means, going back up top, my answer is going to be 14 thirds plus 2 all over 5. I could simplify that. I definitely could do that in algebra or arithmetic, but I don't need to because that's a numeric answer, so I can stop there if I wish. Let's see what part C is about. Suppose g is a function defined by that, where k and m are constants. If g is differentiable, what are the values of k and m? So in order for g to be differentiable, we need the limit as x goes to 3 from the left of g equal to the limit as x goes to 3 from the right of g equal to g of 3. No, not 3, but g of 3. And we also are going to need the next step, but I'm going to put this part first. So let's do this part. G from the left, that's going to be this one. Plug in 3. 3 plus 1 is 4 squared, so that's 2k. And then plug in 3. That'll be 3m plus 2. And then g of 3 is also 2k, so I can stop there. So that's one equation I have. We also need the limit as x goes to 3 from the left of g prime to equal the limit as x goes to 3 from the right of g prime. So we need those two pieces. We need those slopes to be the same. So g prime, I'll write it up here, is going to be, so that's k, and then x plus 1 to the 1/2. So k over 2, x plus 1 to the negative 1/2. That's when x is less than or equal to 0 less than 3. And then m from 3 to 5. Oops, I messed up my equal to there, sorry. 3 to 5, there we go. So those are just those slopes. So from the left, if I plug in 3, 3 plus 1 is 4. 4 to the negative 1/2, I'll have that discussion here. That's the same thing as saying, what's the square root of 4? And that would be 2, and then flip it over because that's negative. So that's 1/2. So that's going to be k over 4, because we have k over 2, and then we have 1 over 2, so that's k over 4. And then g prime from the other side is just m. Now from that equation, can't I then say k is 4m? So then I can claim 2 times 4m is equal to 3m plus 2, which means 8m is equal to 3m plus 2, which means that m, so that's going to be 5m is 2, so m is 2/5, and therefore k is 4 times 2/5, which is 8/5. And I've shown the work I need for those pieces. Now, keep in mind, I need to show the continuity piece. That would be the purple piece up here. And then I need to show the differentiability piece. That would be the orange piece. In this case, I then had a system of equations that I needed to solve. Oh, and that's it. We're done. So let's look at the whole question. We're given this piecewise function. Our first question is, are we continuous at 3? So in order for the function to be continuous at 3, that means that the limit from the left has to equal the limit from the right, which has to be the function value, as we discussed. So a little bit of arithmetic basically there, but we have to check the continuity piece. Find the average value. So average value is add everything up, divide by the width of the interval. So that means integrate from 0 to 5 and then divide by 5. In order to do that integral from 0 to 5, I had to do it in 2 pieces because I have these 2 pieces. Oh, I never discussed that last thing I was going to discuss. So the integral from 3 to 5 of 5 minus x dx, if you had wanted to, you could have done with a picture. So 5 minus 3 is 2, so 3, 2, 3, 2. And then 5 minus 5 is 0, 5, 0. So you could have found the area of that region. This is 2, so the area of that region is 2 because it's a triangle. So that would have been another way to do that integral. In fact, that might have been an easier way to do it rather than the analytic way that I did on the other page. And then for part C, in order to show differentiability, we have to check the continuity piece, which we talked about in part A, and then we have to check the derivative piece, showing that the derivative from the left is equal to the derivative from the right. You need to show all that work in order to justify your reasoning. And let's look at the rubric. We're continuous because the limits are the same and they're equal to function value. We did that. They did the integral in 2 different pieces. Again, I showed you this piece. You could show the analytic or you could just show the picture. It says antiderivative, but if you didn't show that antiderivative and you used geometry, that would be fine also. And then G is continuous, we know that. We've got that, so we plug it in. Okay, so we did all the pieces, and we did them basically the same way they did. They talked about them. So beautiful.